Hey there! Today we're diving into a weather phenomenon that can send a shiver down your spine. The polar air plunge. Imagine the North Pole as a giant freezer packed with dense, icy air, usually kept in place by the polar vortex, a powerful spinning wind that acts like a lid. Most of the time, this vortex keeps the cold locked up, separating the Arctic chill from the milder air where most of us live. But sometimes, the vortex weakens or splits, letting that frigid air escape and surge southward. This is what we call a polar air plunge, a massive, rapid drop in temperature as Arctic air invades lower latitudes. It's not your average cold snap, it's a deep, biting chill, often with dangerous wind chills and wild weather. When this air moves over warmer, moist regions, it can trigger explosive snowstorms and even sea smoke, where the ocean looks like it's steaming. In simple terms, a polar air plunge is when the coldest air on Earth breaks free and barrels south, creating extreme winter weather. These events have shaped winters for centuries, but understanding them is more important than ever as our climate changes. What happens at the North Pole doesn't stay there. It can impact millions far to the south. As we saw in 2026, these plunges can make headlines around the world. So, let's explore how and why these icy invasions happen. Fast forward to the winter of 2026, a season that millions won't forget, thanks to a relentless series of polar air plunges over the Atlantic. Meteorologists dubbed it the Great Chill of 2026, not just for its severity, but for how long it lasted and how many people it affected. From North America's east coast to Western Europe, people bundled up as the cold held on for weeks. The event began with a sudden stratospheric warming high above the Arctic, disrupting the polar vortex. The vortex split into two lobes, one over North America, the other over Europe and Siberia, unleashing waves of Arctic air. The Atlantic, usually a buffer, became a battleground between frigid polar air and milder ocean air, fueling explosive weather. The Great Chill became a case study for scientists and a wake-up call for the public. It showed how a warming Arctic can paradoxically lead to more frequent and severe cold outbreaks. The winter of 2026 wasn't just about weather. It was a climate story everyone lived through. It highlighted our vulnerability to extreme cold, even in a warming world. Understanding these patterns is crucial as we face more unpredictable winters. The lessons from 2026 are shaping how we prepare for the future. How did that Arctic air travel so far south? It's all about the pathways in our atmosphere. After the polar vortex split in January 2026, a massive Arctic high-pressure system acted like a pump, pushing cold air outward. In North America, the jet stream dipped deeply, creating a slide for the Arctic air to rush south, what some call the Arctic Express. As the air moved over the Great Lakes, it picked up moisture, unleashing historic lake-effect snowstorms. Crossing the Atlantic, the frigid air met warmer waters, fueling intense sea-effect snow bands that battered coastal communities. In Europe, the other lobe of the vortex sent Siberian air westward, the infamous beast from the east. The British Isles, usually protected by the Atlantic, were hit with rare, severe snow and ice. The cold even reached Spain, causing shipping chaos in the Bay of Biscay. The journey of this air mass surrounded the Atlantic with record-breaking cold. It was a dramatic demonstration of how interconnected our weather systems are. The 2026 plunge showed just how far and fast Arctic air can travel, and it left a lasting mark on both sides of the ocean. The Great Chill of 2026 didn't just bring a cold snap, it shattered records and brought life to a standstill. The eastern US and western Europe were ground zero. Cities like Chicago, Boston, and New York saw their longest stretch of below-freezing temperatures in decades. Boston hit a record low of -10 Fahrenheit, with wind chills making it feel like -40. Halifax, Nova Scotia, recorded its coldest temperature ever, and rivers and bays froze over. In Europe, the UK saw its biggest snowfall since the 1980s, shutting down airports and isolating villages. The Netherlands, Germany, and even Paris were blanketed in rare snow. Madrid, Spain, plunged to 14 Fahrenheit, with snow causing widespread disruption. The cold reached the Mediterranean, with sea-effect snow on Corsica. The 2026 plunge was a hemispheric event, setting new benchmarks for extreme winter weather. Its impacts are still used as a reference for future cold outbreaks. So, why do these dramatic cold air invasions happen? It's all about the balance between the cold poles and the warm tropics. The polar vortex is key. When the Arctic is much colder than the mid-latitudes, the vortex is strong and keeps cold air contained. But as the Arctic warms faster than the rest of the planet, this temperature difference shrinks. A weaker vortex means a wavier jet stream, with deep southward dips that let Arctic air escape. Sudden stratospheric warming events, rapid temperature spikes high above the pole, can disrupt the vortex, triggering a plunge. This chain reaction starts with a warming Arctic, leads to a wavy jet stream, and ends with bone-chilling air surging south. Paradoxically, a warming Arctic can mean more severe cold snaps for North America and Europe. It's a reminder of how interconnected and complex our climate system is. Changes at the pole can have dramatic consequences thousands of miles away. Understanding this helps us prepare for future extremes. Can we see these plunges coming? Absolutely, thanks to advances in meteorology. Scientists monitor the stratosphere with satellites, weather balloons, and ground stations, watching for signs of sudden stratospheric warming. When the polar vortex starts to wobble, forecasters know a cold outbreak could be weeks away. Sophisticated computer models, like the GFS and ECMWF, simulate the atmosphere and predict the path and intensity of cold air. In 2026, these models gave weeks of warning, allowing communities to prepare. Early alerts helped save lives and reduce disruption. Modern forecasting turns potential disasters into manageable events. It's one of the great success stories of today's meteorology. A polar air plunge like 2026 doesn't just lower the temperature, it sends shockwaves through society and the environment. The clash of Arctic air and warm ocean fueled bomb cyclones, bringing blizzards and coastal flooding. Health risks soared, with frostbite and hypothermia a real danger. Cities opened warming centers and power grids strained under record demand, leading to blackouts in some areas. Transportation ground to a halt. Roads were impassable, flights canceled, and businesses closed. The economic toll ran into billions, from lost productivity to emergency response costs. The environment felt it too. Rapid freeze-ups trapped marine life, and heavy snow damaged forests. Yet, deep snowpack also replenished water supplies and killed off some pests. The 2026 plunge was a stark reminder of our dependence on stable weather. It showed both the vulnerabilities and resilience of our communities. Extreme cold can have both negative and positive impacts. Preparing for these events is more important than ever. The Great Chill of 2026 was a powerful teacher. Early, clear communication from forecasters allowed for a coordinated response and saved lives. The event exposed weaknesses in our infrastructure. Power grids and pipes struggled to cope. Lessons learned are now driving upgrades to make systems more resilient. Communities came together, with neighbors helping neighbors and volunteers staffing shelters. The event highlighted the importance of strong social connections in emergencies. Scientists gained valuable data, refining climate models and deepening our understanding of the polar vortex. The key takeaway: we must prepare for more volatile winters, even as the planet warms. It's not about every winter being colder, but about more frequent, high-impact cold outbreaks. The lessons of 2026 are shaping our response to future extremes. Looking ahead, the big question is, will this happen again, and will we be ready? As the Arctic keeps warming, the risk of unstable polar vortex events remains. We must prepare for future polar air plunges, milder winters punctuated by sudden severe cold. Preparation starts at home: emergency kits, winterizing pipes, and staying informed. On a larger scale, cities need to modernize power grids, improve building insulation, and plan for extreme weather. The lessons from 2026 must drive real action and policy. Adapting to a changing climate means expecting more extremes, not just in winter, but year-round. The Great Chill was a wake-up call. Science, preparation, and community are our best defense. By learning from the past, we can be ready for whatever winter brings next.